So now we're going to continue with setting up the aircraft systems. So we have to go to the overhead panel over here. We're going to want to start the APU. It'll take about a minute to start up. We're going to just go over all panels, make sure everything's okay. I'm going to explain some of this to you right now. So these switches control the yaw damper. That's a mechanism in the vertical tail of the airplane. And airplanes, when they're flying, they sometimes have a tendency to oscillate a little, and the yaw damper will dampen out those oscillations. These here are the hydraulic pumps. What they do is they are first, let me disconnect ground power, remove the ground power unit since we don't need it anymore. The APU is providing us with all the power we need. So the hydraulic pumps, they're used to move the flight control surfaces of the aircraft. And the speed brakes just went up. I don't know why this airplane sometimes glitches a little, but the flight control surfaces, there are things like the elevators over here. They're used to pitch up the aircraft, pitch the aircraft's nose up. The ailerons, which are used to bank the aircraft. And what the hydraulic systems do is they move these flight control surfaces for the pilots when they move the yoke. So in other words, think of it as power steering, but then for airplanes. These switches here control the electrical system of the aircraft. This over here is the evacuation panel. The pilot needs to activate this switch in order to activate the evacuation signal. That is if the aircraft gets in an accident. These over here are the lights switches, the exterior lights. These switches are used to control the fuel pumps. These indicators show how much fuel is in each of the fuel tanks. This airplane has 3 fuel tanks, one in each wing, one in the center between the wings. Fuel temperature over here, the total fuel quantity. These are the anti-ice switches. So now let's continue setting up the aircraft. So what we're going to want to do is go to the autopilot panel. This here is used to control the autopilot. We're going to enter our cruising altitude of 36,000 feet. So when the autopilot's on, the aircraft will never exceed this altitude if the correct mode is engaged. Our airspeed, we're going to select 250 knots. That is it might differ in real life, but for the simulation we're going to select 250 knots, and that is the maximum airspeed you're allowed to fly at when you're below 10,000 feet. Then we're going to arm the auto throttle. That'll automatically control the throttles for us. We're going to turn on the flight directors. What the flight directors are is they are bars that... First of all, let me explain to you what this display does. This here is shows you the artificial horizon, or the attitude indicator. It displays the orientation of the aircraft's nose relative to the horizon. The white line over here is the horizon, the blue is the sky, the brown is the ground. The flight director bars, they show the pilots where they need to point the nose in order to keep the aircraft on the flight path as programmed into the FMC. This here is the speed tape, which displays the speed of the aircraft relative to the surrounding air. This is the analog gauge used to display our airspeed. This is the altimeter over here, displays the altitude of the aircraft, the vertical speed indicator. For example, if the vertical speed indicator were at 1, this would indicate that the airplane is gaining 1,000 feet every minute, so 1,000 feet per minute. Here it will be at 2,000. This is our chronometer and clock. It displays the time in GMT, and the chronometer will tell the pilots how long they've been flying for. These are the backup instruments, which are used in case the main instruments fail, and the pilots will still be able to know like how fast they're flying, how high they are, and what their attitude is. And pretty much all the same instruments are on the first officer's side of the aircraft. These are the engine instruments. They display the status of the engines. So I'm just checking through everything. The next thing we have to do is go here to the radio panel. This is where all the radios are. Right now, since we're not simulating the air traffic control, we're not going to be using most of the radios, but one thing we will use is the transponder. This is a device that sends out a signal to air traffic control and allows them to identify every aircraft in the airspace around them. It also is used to control a system called TCAS, or Traffic Collision Avoidance System, and that detects planes in front of the aircraft, and if they come too close, it'll tell the pilots about any evasive action they will need to take. So we're going to need to test the system, make sure it works.
TCAS test. Pass.
TCAS seems to be working. We can turn on the transponder. We can turn on the fuel pumps since we're going to be starting the engine soon. Another thing we have to do is turn on the fasten seatbelt sign over here. And then we have to turn on the window heats. The window heaters, they heat the flight deck windows, because when a plane goes to really high altitudes, it gets very cold outside, and the pilots want to keep their windows warm. This over here is the bleed air panel, which is used to control the bleed air system. Bleed air can be sourced from the APU or the engines. This is basically the compressed air that I told you about earlier, and it's used to run the packs, which are the devices that pressurize the cabin. And it's also used to get the engines spinning. But before I go more into that, let me tell you about how a jet engine works. So here we have a poster that was created by Rolls-Royce, and it explains the basics of how an aircraft engine works. So an aircraft engine, a turbofan engine, like on the 757, consists of a turbine section, which produces about 1/4 of the total thrust. And then the fan, which is driven by the turbine, that produces remaining thrust, 3/4 of the total thrust. So the first stage of the whole process is where air is sucked in, and then it goes through a series of blades. Here it's compressed, it's squeezed together, and then it enters a combustion chamber where it is mixed with fuel and ignited, and that gives off really a lot of energy, and then it is blown out through these blades over here. And this produces some of the thrust, but what it also does is it drives, when it goes through the blades, it drives the whole turbine, which in turn drives the fan. And that produces the remaining thrust. But with bleed air, some before when the air is squeezed together and before it goes into the combustion chamber, some of it is bled out of this section where it is compressed, and this compressed air is used as a bleed air for the bleed air system. So now let's go back to the aircraft.